So I'm going to work on some assertions for the x64 generator today. And then I'll also work on making the tests a bit easier to use because I'll need to start adding more instructions soon. So we'll start with the assertions. If the destination is immediate, then we'll panic to say that destination cannot be immediate. And then another test to do here might be, for example, if the size is not byte. And the destination is XH or the source is XH. This is the high bytes. Then we'll panic to say that AH, CH, DH, and BH can only be used with size of bytes. Once we know, once we know which operand is the RM field, we'll say that if RM is rel, so this will be rip relative, and there are two checks to do here actually. So if RM is not memory, then we'll panic with rip relative can only be used with memory operands. And if RM is scaled index, we can't use rip relative with that either. So rip relative cannot be used with a scaled index. Let's see, what other assertions could we put in here? If we have a rex byte, so let's see, if we have a rex byte, then if either of the destination or the source is the high byte, then we can't encode that. So AH, CH, DH, and BH cannot be encoded with a rex prefix. Then I think that the only assertions we'll have left here are around the displacement and the immediate. So I want to change these to basically check to see if they will fit within the number of bits that we're supposed to be using. So I'll have a function here called checked uint. Let's say checked uint 8. So this will take in some value, which we'll just call v. So this will be int64 and it will return a uint 8 that has been checked. So we'll say that value equals uint 8 v. And if v does not equal value when it's been expanded back out to an int64, then that must mean that the value does not fit within 8 bits. Otherwise, we'll just return the value. So we need this for 16 and 32 bits as well. We won't bother with 64 bits because we only have 64-bit values, and so those are always going to fit anyway. So this one's 32. So these two byte ones here, for example, will return a checked uint 8. Any append 32s can do a checked 32, and these append uint 16 can do a checked uint 16. Then there's just a couple of assertions to put into the operand building itself. So for example, si here, if O is not memory, then we'll panic to say that a scaled index can only be used with a memory operand. And if the index is, we want to check if this is the SP register, so we'll create a new flag called regsp. Then we'll just say that RSP cannot be used as an index. So we'll need a new regsp flag up here, regsp. And all of these tests should still pass. Oh, okay. In the generator, we need to deal with int 32. This is an int 32. Converted it to 64. This one should also be 64 here. So now we get scaled index can only be used with a memory operand. I think that, so that's multiplied by 2, and it's a scale only, so this will be converted to a base plus a scale of 1. So I think in this case it's just because I'm not explicitly converting this to a memory operand. Okay, so that all passes. So that's all of the assertions done that I want to do. The next step is to change these tests a bit. I don't want to have to keep on specifying size and operands here. I just want to infer them from the instruction text. So let's just get rid of these headings for a second. And I think also we'll just, okay, that will do, I think. So basically over here, I want some function that's going to parse the the test instruction string. So I'm basically just going to write a really bad parser because it's going to expect things to be very strictly formatted. So we'll say, for example, we'll get the mnemonic, the size, op1 and op2. So this will be parse instruction, and we'll pass in tc.ins. We'll then want to switch on the mnemonic, and actually while I'm here, since I'll be adding more instructions, I should panic if I see one that I haven't handled yet. Unhandled mnemonic, and we'll just pass, oh, this will just be plus the mnemonic. Okay, so we need this parse instruction. Okay, let's do function parse instruction. We'll take in the instruction. We'll pass back a mnemonic, a size, and then 2 operands. So for this, I basically want to process the string. So we'll remove all consecutive runs of like multiple spaces and just replace them with a single space. So this will be strings.join strings.fields of instruction with a space. We'll also make this lowercase, so any comparisons are a bit easier to do. And then we'll just start cutting up the string, basically. So, for example, we'll have the mnemonic will always be the first thing. So this is coming from instruction by space. Then we may have an optional size hint, like here we've got mov byte. We'll always expect the size hint to be on the like after the mnemonic. So we'll say size hint, and do I need rest here? Maybe not yet. We'll just try and take a size hint by cutting rest with space again. Then we'll say we want to check to see if we've got a valid size hint, basically. So if size hint is either byte, word, or dword, or keyword, then we want to remove that prefix from the rest. So we'll say rest is strings.trim prefix, and this will be rest size hint plus the space. Then we'll actually want to see what the size hint was as well. So in this case, if it's a byte, then we'll set a size equal to byte. We don't have size yet, so we'll just put this up here. Size is a size. We'll set it as some sentinel value of -1 to mean we haven't figured it out yet, because these hints are only here for certain instructions. So we'll do word, and then this one is dword, and then keyword and keyword. So if size is less than 0, then we haven't figured out what it is yet, and we want to move over some operands to decide what it is. So at this point, rest should be just the operands now. So if we say that rest equals, let's say strings.replace all, we'll remove all spaces at this point. So we'll replace all spaces with nothing, and then maybe what I'll also do is that NASM has a bit of a weird syntax for rip relative, which is rel dollar with a space, but I've removed all the spaces now, so we'll replace this with rip instead. And then what we'll do is get the operands. So we'll say operands is strings.split rest by comma, because all of the operands should be separated by commas at this point. So for all of the ops, so we'll say for all of the operands in operands, we basically want to see if we can match a register name and get the size based off of that. So we'll do, for example, a switch on op and see if it matches one of the byte-sized registers or not. So we'll say, for example, AH, CH, let's see, DH, BH. What else is there? There's AL, CL, DL, and BL. Then we've got SPL, BPL, SIL, DIL, and then we've got the numbered ones, which are going to be R8B, R9B, R10B, R11B, R12B, R13B, R14B, and R15B. So let's just wrap all of these in quotes. Okay. So in these cases, we'll set the size to bytes. The next case, we don't have these high byte ones anymore, so we'll get rid of those. And then these ones become BX and everything, and then these ones become just without the L suffix. The B suffix changes into W for these ones, and this is word. Then we've got EAX, ECX, I think these ones are all just E as the prefix. And then we've got W turns into a D for the suffix. So this is D word, and then finally we have Q word, which is going to be changing all of these E prefixes to R and then removing all of the suffixes from these ones here. So if size is greater than -1 at this point, then we can break out of the loop. And then at the end, we're going to want to return the mnemonic, the size, the op1, and the op2. So we just need op1 and op2 now. So we'll say var op1 is an operand. And so we've got this operands slice up here now. So if the length of operands is greater than 0, then we'll have some other function to get the operand for us. So we'll say, for example, op1 equals new operand from operands 0. And if we don't have an operand, we just leave it as the blank 1 instead. So this is if it's greater than 1, then we use, sub 1. So we need this new operand helper. So this is just going to be some string that's going to return an operand. And what should we do here? We need to check to see if it's a register, memory access, or an immediate. So I think in this case, what we'll do first of all is just say, just as a safety thing, just as a sort of like a check beforehand, we'll say that if it's nothing. No, we won't do that. We shouldn't be passing in nothing anyway. If we're passing in nothing, then something's gone wrong. So we'll just do a switch. We'll just say switch to say maybe like, for example, if the string 0 is a digit. So if it's between ASCII 0 and ASCII 9, then we're going to try and parse this as an immediate. Maybe the default case will be to say that we're going to try and select a register. So this one maybe is like return select reg, where we just pass in the string. This one is going to be creating an immediate. And then the other one is to say that if it starts with an opening square bracket, then that is going to be memory access. So this immediate one, right now we only have hex integers. So we can just do strconv parseInt with a base of 16. But we may have other ones later. So we'll say, for example, if strings has prefix string ox, in this case, we'll want to remove that prefix. Strings.trim prefix. We're going to want to remove the ox so that we can do the parsing. So we'll say value error strconv, parse int, and we'll pass in the string along with base 16, and we'll parse this as a 64-bit. If there was an error, we'll just panic, because we shouldn't be getting an error in these. Then we can try and just return the operand. So we'll say, or maybe what we'll do is we'll say var value is an int64. And then in the else, we can just do the same thing here, but parsing with a base 10. Then we can just return with operand immediate and using the value as the immediate value. So then for the register, we're going to have this select register helper. So this will be a register name here, and we'll have some switch on the name. Maybe we'll do default is the panic unknown register name, and then we'll just append the name. So in the case that it's, for example, AH, we would want to return AH. If it's AL or AX or EAX or RAX, then we'll return AX. So we'll have to do this with all of the first four named ones. So these ones can all become C. This one also should become C. Oh, let's see, C. Then we've got D over here. And then we've got B over here. So ACDB. Then we just need the like stack pointer and things like that. So this one's going to be SPL, then we've got SP, then we've got ESP, and then we've got RSP. So these ones return SP. This one is BP. Then we've got SI and DI. And then the rest of this is just the numbered ones. So we've got R8B, R8W, R8D, and R8 without any suffix at all. So that's just R8. So we've got 9, 10, 11, 12, 13, 14, 15. So we'll change all of the 8s here to 9, 10, 11, 12, 13, 14, and 15. And then we've also got the special case of rip. So we're replacing rel dollar with rip now. So we'll just say return sp in, oh sorry, not sp, ip in this case. So now the memory case is the one that we need to sort out. So what we need to do is say, for example, if we know it's memory, then we want to trim the, let's see, trim, oh my god, trim string. We want to get rid of those square brackets. Then we've got sort of operands within there, which are split up by pluses. So it could be base plus scaled index plus displacement, but all of these things could be optional to some extent. So we could say, for example, we'll start with assuming that the base is at the start. So we'll say strings.cut string by a plus. Then we'll assume that there's a scaled index, and this will be a cut on rest. And then we'll assume that there's a displacement of some kind. But then we need to check to see, so if, for example, the base is missing, but we have a scaled index plus a displacement, then that means that the scaled index is going to be in base and the displacement is going to be in SI, so we need to shift them along. So we'll start by checking to see if SI is, looks like an integer or a number of some kind. Then we'll shift this one up to displacement, and we'll set SI equal to nothing, because if we do have something in SI that looks like an integer, we want to shift that up, but base could still just be a base register in this case, so we don't want to reset that at all. We'll also need to check actually to see if SI actually equals anything before we do this, because we might not have a string there. Then we'll also want to check, for example, if strings.contains, so if base contains an asterisk, then this looks like a scaled index. So in that case, we'll want to move base up to SI and then set base to nothing. So SI should equal base, and then base should equal nothing in this case. Then we need to start building up an operand. So we'll say operand, we'll just assume it's no base to begin with, and then we'll say that if base actually has something, then OP can equal select register, where we just pass in the base. Then we need to change it into a memory operand. Then we need to see if we've got some scaled index. So in this case, we want to cut this to say that we want the index and some number. Strings.cut, we'll do SI, and this will be cutting on the asterisk, because we always expect that to be there for the test cases when we're doing a scaled index. Then we'll need to set the op. So we'll say op is op.scaledIndex, where we select a register using the index, and then we need some scale as well. So we'll say var scale is a scale, and then we'll do a switch on num. The default case will be a panic for unknown scale num. So in the case that it's 1, we'll set scale equal to x1. And then we'll just do this for 2, 4, and 8. And then finally we need to say if we've got a displacement, then this is basically back to the integer parsing stuff here. So we'll just take this value. So if we get this value, but a displacement can only be 32 bits, so we'll parse it as 32. If we get a value then we'll just say op equals op.d. We'll pass in that value, which we'll have to convert to an int32. And then finally, we'll return the op that we've built up. So if I call this, so I'm calling this right now, if I don't use these test case values, all of these tests should still pass. Cannot use bytes in 19. Oh, that's because I've already removed the fields from the test table. Okay, let's just remove the rest of these from here then as well. So we'll want to remove up to here. Okay, let's try this. So here we've got parsing invalid syntax rip plus this thing. So this is doing the memory operand. Okay, so we trim this. Then we try to get base. Okay. We've got rest here. That's being cut as well. And this is panicking on which one? Here. Oh, let's go back into, so we got probably this one. So it's panicking over here. So it seems like we think that displacements okay, what's going on here then? So we've got disp, let's just print these out. So we've got fumpt.println base, si, and disp. So here we've got rip space ox7. Maybe I should do a dot between these so I can actually see which one's which. So rip, and then si looks like this. So if I go past here, now we've got rip in the base, and then si here. Invalid syntax for, oh, this is disp now, which makes sense because we're panicking in disp at this point. Okay. Oh, I see. I've forgotten to, I need to change string here for for disp. Okay, so all of the tests still pass, so that means that we're correctly inferring all of the operands and everything from the instruction string. Maybe one thing that I will do quickly is to just say clean these up. So we'll say word plus word comma word as a regular expression. We'll clean all of these up. Then we'll have a look for all of these ones, and we'll do the same for these ones as well. Then we've got W and then a plus and then W. So that gets all of these ones. Just put some spacing around them to make them easier to read. And then I'll leave the scales as being tightly, packed together like this. Okay, I think that should be about it. So let's just maybe remove these blank lines now. Okay, we should still pass tests here. Okay, that's all working. So With all of those assertions in place and the tests cleaned up and made a bit easier to write, I should be able to now dump just whatever NASM output I get. So next time I'll look at maybe adding some more instructions.